Everyone, I'm starting a new series, and in this series I'll solve all 75 questions in this list of questions. I'll post this list in the description of this video, and what I'll do is I'll create 15 videos, and in every video I'll solve 5 questions from this list, and I'll call this series as 15 Days of Leetcode. So you can try to solve 5 questions every day, and that way you will be able to complete this list in 15 days. So let's start with the very first question in this list, which is to sum. So let's see the first question. So it's a very easy question. You are given an array of integers and there is a target, and you have to return index of two numbers in this array such that they add up to the target, and they guarantee that exactly one solution is present, and you can return the indices in any order. So one idea is to sort the list, and then it would take n log n to sort the list, and then have a pointer at the starting of the list and a pointer at the end of the list, and then take the sum of the values at these two pointers. If the sum is greater than the target, which means you have to reduce the value, then decrease the pointer at the end of the list by 1, and then take again the sum. Let's say this time the sum was less than the target, which means we have to increase. So that's why I'll increase the left pointer here, which is at the beginning of the array, by 1, and this way we'll keep going, and at some point we'll be able to find the target and we can return those indices. But it will have a time complexity of n log n, and if you are supposed to do it in order n, let's say, then you'll be needing something like a hash map. So in the hash map, what will you do is you will store the key will be the value in the array, and the value corresponding to that key would be the index of that value in the array. And at every location you will see whether we have seen the target minus the value at current location previously in the array, and if you have seen it, which means you have found the target sum, and you can simply return the two indices. So for example, at this location you will try to see, have we seen 9 minus 7, because 9 is the target, 2 previously in this array, and yes. If yes, then we just return the index of the current element and the index of the target minus 7, that is index of 2. So we simply return 0 and 1. So this is a very straightforward approach. Let's quickly implement this. So we'll take a hash map. So we'll check if map has already seen that value, target minus num psi. If map already has that value, we simply return index of that value, index of target minus num psi, which is stored in the map, and the current index, which is I. Otherwise we simply store the current value as the key and index as the value corresponding to that key. And here we can return some default value, but this would never be returned, because as it says, exactly one solution is always guaranteed. So we run the code. So our code has been accepted. So this was a pretty straightforward question. There was nothing fancy in this. Let's jump right into the second question. So here this is that you are given a string s, and you have to find the length of the longest substring without repeating characters. So basically you go to A, you go to B, you go to C, and then you again C, A. So length of the longest substring without repeating characters until now is 3. So what I'm thinking is we can use a sliding window. So whenever we get a repeating element, for example, let's say we create the window, we are creating the window, we have created A, B, C, and next we encountered A. So whenever we encounter a element which has been there in the window earlier, which we have seen in the window earlier, what we will do is we will decrease the window size such that that repeated element is no longer there in the window. So we'll decrease the window to BCA. And now again we get B, so we'll decrease the window such that B is not there. So CAB is the new window. We get C, we decrease the window such that C is not there, which we get ABC. And we again get B, so this time we decrease the window such that previous B is not there. So we remove two elements from the window and the new window is CB. So this is the new window CB. And again we get B, so we decrease the window such that previous B is not there and previous B is not there. So we decrease this window and the new window is currently B. So out of all these windows which we have seen, we'll take the length of the maximum window. So this is the approach which we can implement. So let's try to implement this. Let's see how can we implement this efficiently. So firstly we need to keep the index of the latest character. So another map char int map. So initially the left pointer of the window is 0, the right pointer of the window is also 0, and let's say our answer is 0 initially. So we'll go through every character in the string S. We will check if the current character at current position is something which we have already seen. So if map, so current character is simply RSI. So if the current character is in the window, so map will store all the characters in the current window. So if current character is already in the window, what we'll do is we'll get the index from the map where the current character was previously seen, and since we don't want to include that character anymore in the window, what we'll do is we'll start from the left pointer. So for int, let's say remove index is equal to L, and remove index less than equal to index, remove index plus plus, and what we'll do is we'll remove all those characters from our map because we are decreasing the window size. Map.erase, and then after this we'll set our L to be current index plus 1. So we'll decrease the window size. So this code is just decreasing the window size, basically removing all the elements from the window up to the index of the current character. So once we have done that, we can include the current character into our window. So map of current is equal to current index I, and then we can update our answer. Answer is equal to max of answer comma current index minus left plus 1, and we can return answer here. So in fact we did not need this R. Let's try to run this code. Wow. So let's try to submit this. Nice. So our answer has been accepted. So the trick was to have a map, and in this map at any point of time we will only have those characters in this map which are currently in the window. And what we do is we go through every character in the string S. We check if the current character is already in the window. If it is already in the window, what we do is we remove all the characters up to that character from the window. So we find the index of the current character, and then we remove all the elements from the map up to that index, and then we increase the leftmost pointer. Basically L is keeping track of the starting of the window, so we appropriately adjust the starting of the window using L, and then we add the current character into the window, and then this is the size of the current window, and that's how we are calculating the maximum window size. In fact, if you realize, we don't even need to remove the elements from the map if we add a particular optimization, and that optimization is this. So we can skip removing these elements, and instead what we'll do is we'll see that okay, if map contains the current character, but is the current character part of the window, and window is defined by our leftmost pointer L. So we'll also check that our L, so if L is less than or equal to map of current, only then we know that the current character is part of the window. And if it is part of the window, what we'll do is we'll increase the L to be such that that character is no longer included. So we'll just increase the L to be this, and I think this should work also. And this slightly improved our runtime from the previous case. So from 24 milliseconds to we are just now taking 12 milliseconds, which is a good thing. So this is a slight optimization you could do. So instead of removing the elements from the map, you could just check the value of L and just check that the current character is part of the window or not. So I hope this question is clear. So let's move to the next question. This is a very popular question, longest palindromic substring. So given a string, we have to find substrings which are palindromes, and among those substrings we have to return the substring with the longest length, and there might be multiple substrings with the longest length, and we can return any one of them. Any of them is a valid answer. So there are multiple algorithms which exist for this problem, and there is even an order n algorithm which exists for this problem, but it's slightly complicated. You can Google for order n solution if you want. In this video we'll be discussing order n square solution, which is often acceptable in a 45-minute programming interview. So what that does is it tries to find a palindrome, assuming, let's say, this is the center of the palindrome. Let's say A is the center of the palindrome, and it tries to find the palindrome given A is the center. So it tries to expand towards its left and towards its right as long as those values are equal, and then it finds the length of the longest palindrome centered at A. So that would take order n, and it does it for all the centers. So there can be order of n centers, so that's why overall time complexity is order of n square. So there are two kinds of centers. So first center is this center A, but there can be other center. For example, here there is a center between two B's. So if you expand around this center, which is like the empty space between two B's in this example is a center, and if you expand around that, you will find a palindrome B comma B. So that's why there are n letters and n minus 1 empty spaces between them, and that's why we have n plus n minus 1, which is 2n minus 1 centers. So let's implement a function expand from center. So for this kind of center, what we have to do is we'll pass the index I and j to be same here. So basically 1 comma 1, so it will start from here. And for this kind of center, we'll pass the index I and j different, so we'll pass 0 and 1, so it will start from there. So we'll pass two indexes, and so initially length is 0. So what we'll do is, if let's say we pass the string as well, string s, so if s of I is equal to s of j, we simply expand around the center, so we decrease the I and we increase the j, and then if they are not equal, we'll just stop there. And length of the palindrome is simply j minus I plus 1. That's the length of the palindrome given the center. So we can simply return this length here. So in fact we don't even need to use this, we can simply return this. So for our answer, let's say we store our answer left at 0, answer right at 0. So basically whatever is the answer substring, we store its left index and right index, and then we calculate the length of the palindromic, and we calculate the length of the palindrome given the center I comma I, and we can pass this by reference. And similarly, we can find the length given the center I comma I plus 1. Sorry. And actually this is not if, this is while. So while they are equal, we keep decreasing this and increasing this, but we also have to check that I has to be greater than 0 and j has to be actually less than the size of the string. So making these sanity checks, and then we return the length. And we check the maximum of these two. So if this is greater than our current answer, which is answer right minus answer left plus 1, So if the length is greater than that, we have to update our answer right and answer left. So how can we update that? So we know that if, let's say, length was, so in this case let's say length was 3. So since length is 3, so 3 by 2 is 1. So which means that from the current index we go one index left. Here the length is 2 and the current index is 1. So 2 by 2 is 1. So we go one left. So but we don't want to go one left. So what if we subtract 1 and then divide by 2? So for example, in this case length is 3, length minus 1 is 2, 2 divided by 2 is 1, so we still go 1 towards the left. In this case the length is 2, we subtract it with 1, so 2 minus 1 divided by 1 is 0, so we go 0 left. And for the right, we can simply divide length by 2. So the amount of left steps we have to take is len minus 1 by 2. So L minus 1 by 2 and left steps and right steps equal to simply L by 2, and we can update our answer left is equal to the current index minus left steps, and answer right is current index plus right steps. So this is just a nitty-gritty details of taking care of some nitty-gritty details, and once you have got your answer, you can just return your substring and you add +1 because it ignores the last index given in the substring. So we simply return that. I think it's called substring, and instead of the rightmost index we have to pass the length of the substring. So length would be answer right minus answer left plus 1. So let's check now. So let's do some quick debugging. So let's do quick debugging. So for index 0 it's giving length of 3. That's weird, because for index 0 it should give length of 1, and for index 1 it's giving length of 5 while it should give length of 3. So it is giving an extra length of 2. Why is it? So for index 0 let's also add length 1 and length 2 here. So length 1 is giving the wrong answer actually. So length 1 is when I is equal to j, so when 0 is equal to 0. So here length is equal to 1, this is satisfied, this is satisfied, and si is equal to sa, right? Oh, I see. So here s0 is equal to s0, then I and j increase, and that's why length increase, but actually we do not have to increase the length here actually. So instead what we can do is, so once this condition becomes false, we can return j minus I minus 1. This should work for case 1. For case 2, let's say for index 1, si equals to sj right, and then I and j would become this. They are still equal, I and j would become this, and should work for case 2 as well. So let's quickly check. So if this condition becomes, if this internal condition becomes false, then we can use j minus I minus 1, because current I and j are the pointers outside, just outside the string we actually want. So this works okay. So let me comment this C out and try to submit the code. Yeah, so the code has been accepted. So the problem was this function was returning the wrong length, but yeah, so there are few things, few minute details that you have to take care of in this question, but yeah, otherwise it's not that difficult question. Now let's jump to the fourth question in the list, container with most water. So we are given n non-negative integers a1 to an, which represents the height of the bars as shown in this figure. So the height is 186254837, and we have to find two such lines, the vertical lines, such that we can contain maximum water between those two lines. So for example, let's say between these two red lines, the maximum water which can be contained is the horizontal distance between the lines, which is 1 2 3 4 5 6 7, and the length of the shorter line between the two, which is also 7 in this case. So we can fill this much of water, 7 cross 7, which is 49, between these two red lines, because any more water would be spilled, because any more water between these two lines would be spilled, because the amount of water which these can hold is limited by the shorter vertical line. So we have to find the maximum amount of water which can be stored between any two lines among all the vertical lines. So this is a very interesting problem, but the solution is quite simple. It's not intuitive in the first go, but it's actually very simple. So let me describe. So for example, let's try to see the rectangle with the maximum width which we can form. So maximum width would be between the first bar, the first vertical line, and the last vertical line. And the amount of water which it can hold is limited by this smaller vertical line. So it would be 1 cross 8. That's the maximum amount of water which can be held if we consider the first and the last vertical lines. So now if we try to remove this rightmost vertical line and keep this leftmost vertical line, so for any vertical bar, all these vertical bars will form lesser area with this leftmost vertical line, because the horizontal distance is getting decreased and vertical distance is limited by this line. So all those possibilities are ruled out. The only chance of getting a larger area is if we ditch this shorter height vertical line and move to the next line and check our luck here. So we get these two red lines then in the next case. So we ditch the smaller one and we move on with the 8, and here also we calculate the area, which we get the 49. But now let's say if we ditch the bigger line, any line we pick from all these lines here, 1 2 3 4 5 6, so any line which we pick from all these lines would make less area with this line, because the horizontal distance is decreasing and vertical distance is not increasing. So that's why we don't ditch the bigger line, we ditch the smaller line. So in this case we ditch 7, and then we basically check from 8 to 3. So after checking from 8 to 3, we ditch the smaller one again, we check from 8 to 8. So when both of them are equal, we can ditch any one of them which we want. So we can check from 6 to 8, or we can check from 8 to 4. It won't make a difference. And the reason is, since both these are equal, 8 and 8, we can get a bigger area only if we have two vertical lines which are taller than 8, because otherwise we can't make a bigger area with 8, because 8 would limit the maximum width, because 8 would limit the maximum height and we are decreasing the width. So basically we can ditch any of the 8s. That's the moral of the story. So let's ditch the second 8. Let's continue with this, and we check the area again. We ditch the smaller one. 4 here, we check the area again, we ditch the smaller one. 5 here, we check the area again, we ditch the smaller one. 2 here, we check the area again, and then we ditch the smaller one. So basically when there are only 2 vertical lines left, that's the last area which we have to check. So basically just a simple plain order and solution. Let's implement it quickly. So let's say initially answer is 0 and L is equal to 0 and our right pointer is equal to size of the array -1, and while L is less than R, we calculate the area is min of L comma R into the horizontal distance is right minus left. And answer is equal to max of current answer comma area, and if L is less than R, if height corresponding to L is less than height corresponding to R, we increase L, else we decrease R, and then we can return answer. This should be T. Where did I screw up? Here I have to take the height. Super silly mistake. Let's submit the code. Wow, last I solved this question in 2020. So yeah, solution has been accepted. The idea is a bit tricky, but the code is very simple. So let's write straightforward jump to the next question, and the last question for the day. Which is 3 sum. So given an integer array nums, return all the triplets nums I, nums j, nums k such that indices are not equal. I is not equal to j, I is not equal to k, and j is not equal to k. So distinct indices, and nums I plus nums j plus nums k is equal to 0. Notice that the solution set must not contain duplicate triplets. So we also have to rule out any duplicate triplets as well. So we have to find all triplets such that the sum is 0. So it's similar to 2 sum, but there is a slight difference. There also we were doing like we were storing in hash map to find a corresponding integer. So here also we can do this. Let's say for -1 we try to find 2 more integers in the remainder of the array whose sum is 1, and to do that we can again follow the same hash map approach, which will be space of order n and time complexity of order n, which we can definitely do that. So this we would have to do n times. So this would be order of n square and space complexity of order of n. But we can do it in a better way by first sorting this array, and we can sort this array and still get the we can sort this array and we still don't have to worry about the exact indices of the original elements, because we are not returning the indices, we are returning the numbers itself. So if we sort the array, then we can do the same approach, but instead we can use two pointers instead of the hash map to find the remainder 2 arrays, as we discussed in twosome. So in short, we can do something like this. So the bit complicated part of the code is that we have to remove the duplicate. So for that we have to take care of few things. So let's see, first we sort the array, because you don't have to worry about the indices, so we can easily sort the array. So we'll go through all the elements in the nums up to this element. We'll go to -1, 0, 1, 2. So that's why I took nums.size -2. So the current element is num_si. Now we get 2 pointers, one is at i+1, another one is at nums.size -1, while l is less than c, if current plus nums_l plus nums, let me make it r, nums_r is greater than 0, which means we are greater than target. So we decrease our r. If we are less than 0, we increase our l. Else we have found a potential solution. In fact, we don't need current, we can simply use num_si here. So, and we can return answer. And here we can do l++ and r --, so that we can look for more solutions. So this code is okay. The only problem with this code is that it does not deal with duplicate triplets. L less than r. What's current? Oh, we haven't defined answer. Oh, too many silly mistakes. Yeah, so as I said, the code is correct, but it will contain duplicates because we are not dealing with duplicates in this code. So to deal with duplicates, what we have to do, so let's see what happens when we sort this array. So now in this sorted array, we can see that for -4 we didn't find any solution. For -1 we found two solutions. So one of the solution was this -1 and 2. So we found this, we increase our L, we decrease our R, we found another solution which is -1, 0 and 1. So we found two solutions for this -1, and for the next -1 we again found this same solution again, 0 and 1. So we are not dealing with duplicates here, and to deal with duplicates what we can do is, since we have found all the solutions with this -1, including the solutions which will not contain this -1, so those solutions would be repeated when we'll include this -1, and we'll try to find, you know, solutions with +1 in this remainder of the array. So the solutions for this and this would be same to this and this, and we have to skip those solutions. So basically what we can do is we can check if I is not equal to 0 and nums of I plus 1 equals to nums of I minus 1. So if previous element is equal to current element, like this -1 is same as the previous -1, we just skip processing this element and we just continue. So we have dealt with some duplication, and in this case this code, for this example I think it should give correct answer now, but this is not still correct for now, because imagine what would have been the case if we would had something like this. So in this case, when we were at this -1, we first find this solution -1, 2. We increase the L and decrease the R, then we find the solution -1, 0, 1, and then we again increase the L and decrease the R, and then we again find the solution 0, 1 here. So again we'll get duplicate entries, and to avoid that what we can do is we can increase the L, and we keep increasing L if current value of L equals to previous value of L. Similarly, we decrease the R and we keep decreasing R if current value of R is equal to the previous value of R. So here we'll avoid skipping, so if we use this, we'll avoid these cases, we'll avoid processing these 0, 1. So now I think this code should be correct and handle, oh, I missed semicolons. This should be L minus 1. So now this code should handle all the cases, apart from the cases where the nums vector is empty. Basically, if nums dot size is less than 2, we return empty array answer. So this should work now. Yeah, so this is working. It was slightly complicated, I would say. So taking care of the duplication was the most difficult part, I would say, in this question. So we need to figure out how to handle the duplicates. So that's it for today. I hope you liked this video. Give me the feedback how I can improve future videos in this series, and if you like this video, don't forget to like, subscribe my YouTube channel, and feel free to comment if you feel that I missed something or something I could do better. I always appreciate those comments, and that's it. I hope you like the video. See you in next video. Bye bye.